Just now we were talking about it, right? The toilets have a particular fall so that water can move in this case. Alright, we are going to use the roof as an example, and please open up 06, number 06, exercise 06, flat roof. It's called a flat roof because it looks like it's flat, but again in reality a roof is never ever flat, even though we call it a flat roof, because we just simply cannot afford to allow the roof to become a swimming pool. In a thunderstorm situation, if the roof is flat, the water do not move. Okay, it stagnates there, it builds up. If too much dead leaves, because we like vegetation so much, right? So we grow so much trees shed leaves. Leaves come down, hydrostatic pressure pushes down, right? Water is heavy, pushes down, flow, choke onto the floor trap. Choke, forms a waterproofing membrane built out of leaves. Water builds up, becomes a swimming pool. Swimming pool, water's pretty heavy. Water got weight there, by the way. Small like that, okay, I can manage. But then you have a huge swimming pool, it's a couple of tons there, okay, weighing onto the roof, which is not designed thick enough or not designed to become a swimming pool. So what happens is water builds up. First things first, because of the structural deflection drops, waterproofing fails, opens up cavities, water drips. Okay, hold it there for too long, cannot hold the weight, what's going to happen? Collapse. Okay, roof, it will result as bad as that. Waterproofing failure, it will happen. Okay, that's the first thing first. You see one roof leaking, you better pay attention to that, because you will lead to worse things. So in reality, not likely to happen. We need to design it in such a way the roof always is never even, so that water will fall. And at its lowest point, we will open a hole there, we call it a floor trap. We allow water to flow there. How do we do this in Revit? We will select the roof. We will click on Add Point. When you select the roof, the flat roof, there will be an Add Point option there. Click on Add Point. It becomes now green color in hidden line. I want you to click 1 point here, 1 point here. Accuracy is not what I care about at this point. Just plonk in 2 of those. That's all. After this is done, click on Modify Sub-Elements. And then click on the first datum point here. You will find that after you click on this, the number appears, a number 0 appears. 0 meaning it's now a flat roof, right? That's why no level change, so it's 0. Put that number to say 300. There will be a prompt here saying thickness of this roof may be slightly inaccurate due to the extreme shape editing. Dimensions to this element in sections and details may not accurately indicate the thickness shown in the type properties. Don't worry about this for now, we'll deal with it. And I'll show you what the problem with doing this is later on. Close this. Alright, do you now see that this floor, this flat slab now begins to look triangulated? Okay. Now, same command again, click on the second one here, click on the number, change the number to say 100 for now. If you look at this now, this floor slab no longer looks flat, it looks like it's a whole combination of triangles. Why triangles? If you think about it logically, a little bit harder, when you have 2 points, you have a what? You link up 2 points, you have a line. Okay? When you link up 3 points, you have a shape. When you have a shape, you fill up that shape, you have a surface. So therefore, 3 points is the absolute minimum required, absolute minimum required number of vertices in order to form a shape and in order to form a surface. Click on this, finish. Okay. I want you to open up, however, here though. Once you have this, I want you to open up section 1. Look at section 1 now, the right side diagram here. This one. I'll just isolate this and show you. Isolate these elements here. Now, this is the thickness of the roof slab at the moment. Okay, it now looks like it is tilted here because we set two different points, of which two different roofing points for it to go up and down. It now looks like thickened. Okay, it's tilted already. Same thing, you can apply the same principle taught to you here on toilet flooring. Okay, if you need it to fall in a particular direction, this is how you do it. You define a point, it will drop. That piece of slab is going to drop accordingly. Alright? It is like that. That was the error message. It doesn't accurately reflect thickness and so on. In reality, when you construct this, when we really construct this, we don't construct it like that. We construct this lower portion here as flat. And then we build materials up here in order to create that difference in levels in order for water to flow. Okay, we either add more material, more cement, more concrete, and then things will flow down accordingly. Alright, with this, how to tackle this? We can make Revit's material reflect this change. Alright, select this and click on Edit Type. We don't want to destroy this particular insulation on metal deck EPDM setting for this floor slab or this roof slab here. We are going to click on Duplicate, and with this I will add one more word, call it Variable. Variable because it changes, the thickness itself will change, and then click OK. And then I will edit the structure of this material under the thermal and air layer. I'm just going to put this one variable here. Once I've done this, I'm going to click OK and OK. So we make the thermal layer here change and increase the thickness here. Okay, now you see this. The base here appears as a straight line, but when you cut a section through it, it looks like it's tilted a little bit and then it falls nicely. This is an exaggerated example. In reality, again, if you remember this, the ratio being 1:200. Every 200 mm will you see 1 mm of gradational difference. Alright, if the roof is 200 meters long, only then you will see 1 meter of difference. So that fall is actually pretty gradual. Once we're done with this, I'll just reset the view again so you can see this like that. Alright, that's how we deal with flat roofs. Okay, so we will close this now.